Hi, everyone. My name is Siamak Paulson, and welcome to this episode of my podcast. In this episode, I'm talking to Marcelo Llano, and I'm very happy to have you here, Marcelo, on this episode. Good morning.
Hello, good morning, Siamak, and thanks for the invite. It's my pleasure to be here.
Very good, very good. Um, I start with the question I ask every guest that I have on this podcast, Marcelo, and that's about your career, your background. If you can give us a little bit of um, background and where did you start in your career and how did you end up in geoengineering and tailings engineering?
Yeah, it sounds good. I'm Colombian originally. I did my undergrad at the National University um, in Colombia, and I started working in 2009, doing some investigations in the Amazonian jungle. But then soon after I moved to Brazil and I continued to work full time while I was doing a master's degree, and then I also did a PhD degree
Mhm.
before in Brazil as well, before I moved to Australia in 2014. And that was probably the year when I started working in tailings. Around that time is when David Williams hired me to be one of his postdocs. And up to that point, I was mainly working. Well, I had worked on mining before as well, but like mostly closure projects. But like the small operations, mostly quarries, really more so than mining.
Mhm.
But then like since I started working with Professor David Williams, then just like my career sort of like diverted towards mining mainly, and then after working a few years as a postdoc, I moved into more industry uh, kind of uh, kind of roles, and I've been consulting here in Australia since then.
Perfect, perfect. And this is a question I ask most of the South Americans. You can speak multiple languages, right? Because you moved from Colombia to Brazil, like a Spanish language to Portuguese, and then to Australia, English.
Yeah. So like Colombia is sorry Spanish speaker, and I had to learn Portuguese when I was in Brazil, and then I moved here and I had to learn English as well. So it's been part of the process really. And you learn a lot while you learn languages, as you know.
Yes, yeah, perfect. Very good. So, Marcello, I think one of the topics that you always have spoken about is risk assessment, obviously, in tailings dam. And I just want to ask you about the challenges there. What do you see the challenges in terms of like the risk assessment in mining and tailings in particular?
So that's a topic that has been present in my career since I started. One of the first assignments that I did while I was still in Colombia was about estimating probability of failures for natural slopes, and that's when I started when my interest in risk started really. And as we know, risk is a function of two key variables. So like that's how we understand it in the industry. One being the likelihood, and the other one being the consequences. Um, Soon after, when I started diving into the likelihood kind of assessments, and when I moved into research, I started focusing more into the consequences. Um, Some of my PhD work was about just like modeling runout in landslides, and then when I started working in tailings, about dam breach consequence and that sort of thing, right? So when you put risk into that framework of likelihood and consequence, and then just try to apply that to um, TSF, so like tailings storage facilities, then you realize that okay, you need to quantify likelihood, and when you're trying to quantify likelihood, you're trying to define which event, which is your failure mode.
Mm.
And when you look at the recent failure modes, or like the most publicized events have been, say, static liquefaction, for instance.
Mhm.
one question that you can ask to some of the tailings practitioners that might come to your podcast is like, okay, how do you quantify the probability of failure for static liquefaction? It's not easy, it's not straightforward. For seismic, we sort of know there are like procedures that we can follow. We know the frequency of these events, right? So we do probabilistic analysis on like the seismic excitation, but for static liquefaction, it's rather difficult. It is like it's definitely not straightforward, right? So that's one component of the risk matrix, right? And then you have the other component, which is the consequence, right? So then historically in tailings dams, most of the methodologies that exist to assess the potential consequence of a failure come all from the water industry, right? So assume that tailings will behave like water. So some people erroneously think that when you assume that tailings behave like water, you're being conservative, and being conservative is good, right? But that's not necessarily the case. Like maybe you will calculate like a larger footprint of like a flooding, if you like, and then people say, okay, yeah, that's we are being conservative because of that, right? But I can tell you from experience, being in multiple mine sites, when you speak to the contractors working inside, and they've seen those flooding maps, and they think it's not a problem if TSF fails, because if something like that happens, to their opinion, it's like they're going to have water standing up to the knees. So they don't see their perception of the risk is completely different to what the actual risk is, right? When you tell them, and also had these conversations with them, and it's like the dam breach analysis may be not accurate, and the reality is that you're going to have like 3 or 4 meters of mud standing above you, then their faces changes and the realization kicks in. That the perception of the risk has been misconstructed by what was assumed as being a conservative assessment. Right?
Exactly.
So there you go. You have like two components there. Like one's being like the likelihood of events such as a static liquefaction that we do not know how to quantify well, and we also have like the other component of like the consequences, or like how do we quantify those potential consequences, which and it's a challenge that we face every day, and we will continue to try to solve in the years to come.
No, that's very interesting. I think you mentioned about water industry and dam engineering in general, because tailings dams are dams, or are considered to be dams, and that sort of changes a lot of things. And when you think about people working around tailings dams mostly see some sort of solid or semi-solid, or a combination of liquid solid. It's not necessarily seen as a water dam, but yeah, that's a really interesting description of the tailings dam in terms of the consequences, especially. The other question I was going to ask you, Marcelo, is about new trends in tailings dam industry. So some historical challenges that we've seen, especially when we assess the risk for tailings dams, and then we're looking at some new trends coming, like new technologies, also new approach to risk assessment. What's your opinion on that? Where do you think the industry is going, and how do you see those new trends?
Yes, so we touched a little bit on like so some of those challenges, right? So the solution, one of the solutions that the industry has come to tackle this is say, okay, we know that tailings are not water, right? But they can go through what we call a phase transformation process during a dam breach, say, right? So you have something that is a solid or is perceived like a solid, and then when it flows, becomes a liquid. When it becomes a liquid, it does not flow like water. It flows from a physics standpoint, it flows as like a non-Newtonian fluid. So like honey or mayonnaise, if you like. Right? So one of the recent trends in the industry is like, okay, the understanding and realization that, okay, if these behave like a non-Newtonian fluid, like then we need to use models that are adequate for non-Newtonian materials, right? So probably one of the most recent advancements in the industry, or like their acknowledgement, was done by the Canadian Dam Association, and then they issued, which is in my opinion, one of the best guidance notes that exists today to assess dam breach analysis. And it recognizes the role of non-Newtonian behavior and the role of variables like yield stress and viscosities in the assessment of the potential consequence. So that was definitely a step forward. A lot of challenges remain, even though that was really good. That is a really good document. We are still trying to streamline those processes, trying to streamline the constitutive relationships that we use in the rheological space. It is a relatively new area for geotechnical engineers, hydraulic engineers, right, and tailings engineers overall. So that piece of document was released like less than 5 years ago, and like we've learned a lot in the last couple of years. And we will continue to learn. Like, I mean, not everything has been said in the topic, so there's like a heap of new documentation that is being released as different consultants, software developers as well as learning. Historically, the software developers have been developing these tools for people working in the food industry, for instance, to work in other different fields. And then we came in, like the tailings industry came asking for these different tools to solve our problems. And then there's like challenges and limitations that that need to be overcome. So that sort of like has been the trend in the area of like quantifying consequences, if you like. To my disappointment, if you look at the other area of quantifying likelihood, there's nothing much in the last few years. When you look at likelihood, like there's a very famous paper published by Silva in the SSE journal that everyone uses it, and it is a direct relationship between factor of safety and probability of failure without much regard for the actual material variability that you find at a facility. So that front of work still needs to be tackled, and there is a lot to do, but more or less that's where we sort of are in terms of quantifying risk for the industry.
Well, I think you pointed out about the technologies, and I was going to ask you about, we hear about the technological advancement, in almost in every aspect of engineering, more related to the tailings management and geotechnical engineering. We hear about some of these developments also happening in this space. What do you think about generally just about technological advancement or developments, and the methodologies that can help basically improve the risk assessment?
Yeah, so I mean, overall, there's been a trend in the industry, like say, like in the last maybe 8 years, and I'm part of that, whereby the industry, looking at all the challenges that we're facing, then had to go and look at academia and trying to find solutions. So like you see a bunch of people now with PhDs that 10 years ago wouldn't have been considered for a job, being hired by different organizations, right? And that has facilitated a lot of like transfer of knowledge from academic settings, if you like, into the industry, right? And I'm probably a product of that trend. My PhD, for instance, was about developing, or like just trying to assess the use of a tool, a numerical technique that is called material point method, to model landslides. And I still remember the day that Professor David Williams saw my presentation as a PhD student, and he said, "What you're doing has an application for the tailings dam industry, for dam breaching, right?" So I worked for him for a few years. Then I started working as a consultant, and people start asking questions about it. one of the reasons I moved away from academia is because I really didn't have an interest to keep working in that area. I think I had enough, I guess. I had solved all the questions that I had. But when people start asking about MPM, I was like, well, yeah, I can help you out. And during the last maybe 5 years, we've seen like a significant trend of more and more clients asking for this kind of assessment to try to refine their estimates on, again, like consequence assessment, using all these like novel modeling techniques. If you go and look at the guidelines, there's not much written. So pretty much it is people like me and others. I'm not the only one. This is a big trend in the industry. There's a few words here and there in the technical guidance notes about the open or the opportunity to use these tools as something that is going to come in the future. But as you know, like, I mean, guidelines documents are always like lagging a little bit behind, and it will likely come in the future. Hopefully, I hope it comes in the future, and it will is the pathway for us to use these tools, and just like bring awareness as well, because not many people know about it.
Sure. No, that's very interesting. And Marcelo, I was listening to your conversation with Brian Ulrich, our mutual friend in America. So one thing that was interesting to me, and if you're happy to speak about this here as well, is I think some of your recent presentations in the conferences and some of the updates of the work that you do in that space. If you're happy to talk about those for us here.
Yeah. So over the last few conferences, we have been publishing a lot about performance-based design. So one of the I want to say novel things, but I mean, we know that the literature exists for many decades, which is about performance-based design and moving away from just looking at factor of safety alone. But there's a lot of things that we need to learn about performance-based design. We don't really know like how to define, okay, what are going to be my KPIs? Like, I mean, we sort of like know who are those when it comes to like to pore water pressure maybe. So we are not too bad to estimating those. But say when we want to try to define what's acceptable level of deformation for a TSF, that's a very tricky question, and it's not very easy to solve, right? So that's one of the one of the trends that we've been publishing a lot recently. Just trying to understand better what performance-based design means, what is actually achievable for us in the industry, and trying to just like lead the charge in just believing what the guidelines are saying and just like trying to walk the talk. We know like all these things and concepts are fairly I'm not going to say fairly old, but they've been there for a while, and it's just the lack of application that is I guess, it's there. So just working on that. We have been working a lot again, on all these some of the topics that I touched before. So a bit of rheology as well. A lot of the stuff that is done in rheology is done at the laboratory scale. So one of the things that I've been working on is like, okay, how can we apply all the rheological testing protocols into the field as well? So that has come hand in hand with a lot of the developments that the site investigation industry is doing. So like right now, we can do vane shear testing at a very high rates of rotation, which pretty much emulates what a rheometer does in a laboratory setting. So you can do all that stuff in the field as well. And then having all the advantages of measuring things on a larger scale, on real site conditions, and so on and so forth, right? And definitely, obviously, like, I mean, large deformation modeling, consequence assessment using the material point method, which is handy as well, just like bringing in more awareness and publishing our case studies when we can, because obviously a lot of these assessments are like highly sensitive, so you got to be careful in what comes out there. But I mean, when we can publish things and then promote that line of work. Yeah, we do that as well.
Perfect. And if our audience were keen to see your presentation, or is there any upcoming conferences that you're going to present? If you want to talk about that, or
oh yeah, of course. Like, I mean, we have the Queensland Tennis Group here in Brisbane. It happens every 2 years, and our headquarters is here in Brisbane. So we are trying to make a big show off. We're trying to, at least. So yeah, just like getting all our engineers here in the office motivated, trying to like publish all the good work they do. So obviously an invitation for everyone as well to attend the conference. Is one of our key conferences here in Australia. It's not as big as say the North American conference, but I mean, it's good for the industry to gather, to come together and share their experiences.
What is it called? And maybe the web address if people want to have a look.
So it's organized by AOSIMM. So it's the AOSIMM conference, and this time around we're going to be combining the Mind, Waste and Tennis conference with the Life of Mind conference. So we're gonna target a larger audience, and I think it's gonna be happening mid-year, around June. So if you get into the AOSIMM website and look for conference and events, like you surely enough you're gonna find it there.
Perfect. Very good. And the last question about your career again, Marcelo, if you want to think about a highlight in your career, you know, the years that you worked in academia and in industry, in consulting, what will be that highlight and why?
Yeah, look, like my background is rather, say, like desk based. So I've been a consultant for most of my career, but I did spend 4 years, almost 4 years, in a gold mine in Papua New Guinea as a field engineer. It is a mine site that is being developed inside a dormant volcano. So we drill boreholes and we recorded temperatures, like the core is coming out of the ground at like above 100 degrees per Celsius. Installing instrumentation in that environment, like extremely challenging. BWPs needed to be like temperature rated. Installing like temperature gauges. We were designing a coat of wall in that mine site. So like, just like a lot of field trialing, grouting, plastic concrete. It was just like an exciting time of my career, and it transformed the way I look at engineering. When you're sitting in front of a desk, like, I mean, things look in a way, and you don't really understand how things are done until you are on site, and you're just like trying to move big pieces of gear when you're trying to get a production going. It can be just compact, like conventional compaction, or just like something like more significant, like just like manufacturing concrete, for instance, or manufacturing grout. The challenges that you face on site they're just phenomenal. It's exciting to be there, to be part of all that, making sure that everything that has been designed in the office actually comes to life. Is definitely very, very excited. And for people out there that maybe have like a more, say, academic background, if you like, I mean, they should spend a few years on site, because it's very enriching, and I don't regret a minute of the time I spent there, and I look at it back in the town like very fondly. I'm very grateful of having that experience.
Excellent. That's really, really fascinating. And obviously a good advice for younger engineers there, you know, just always be open to those opportunities to go out and experience firsthand, like, you know, in the field. That helps with, you know, everything they do in their future in engineering. Very good. I'm really enjoying our conversation, Marcelo, but this is what we have time for today. Hopefully we see each other in one of the upcoming seminars or conferences very soon. But thanks again for your time, and thanks for the audience watching this episode with us. And we catch you in our next episode. Thank you.
Thanks for having me, Siamak. Bye.
Thank you. Bye.